as I told you that potential energy is of two types. Actually, mechanical energy is of two types, in which there is potential energy and kinetic energy. Kinetic energy, we did that, it was half mv square, and we have done all the derivations and the type of questions in there. Now, today we will be talking about the potential energy, which is again of two types. Which are those two types? It is energy due to configuration and due to gravity. Now students, what do you mean by the configuration? See, the constituent particles of any substance or matter, they might change their shape and they might change in their texture, so that it has some energy. There are two properties of any matter which can be explained on the basis of elasticity. One is plasticity. Plasticity is a property of the body in which a body will never regain its shape again back when the external force is removed. So, no regain of shape after removing the external force. Now, what is this? Suppose, I give you one example. Suppose your mother is with a flour, she is making a dough of that chapati to make with. Now, what happens is when they press it, it will never come back to its original place. This nature is known as plasticity. Now, another property is elasticity. Now, what is elasticity? In this, body will regain its shape after removal of force, that is external force. Now, this is the property which is stored, which helps in storing the kinetic energy due to the configuration. See, I'll give you an example. Look here. Suppose there is a board like this and it's a spring here. I apply a wooden plank over there. Now, when it is compressed inside, if I'll compress this inside, what will happen? This will be, spring will have this shape, and if I keep a ball here and the moment it is released, what will happen? This will go and strike this ball and ball will start moving. So, where did the energy come from? Because the ball has the kinetic energy, and where did the energy come from? It was actually the kinetic energy stored, it was actually the potential energy stored in the spring, which is given by half kx square, where k is the constant for that spring constant we call it. Is it clear? No. The thing is, this is one type of energy. Now, I will tell you about potential energy due to gravity. For elasticity, I will give you one more example, that is the catapult. You must have heard of that, in Hindi we call it gulel. So, what happens is, if we tie a stone, it looks like this, and a string is lying here like this. So, what happened is, when we hold it and we tie a stone or ball on it and stretch the rubber with that, so what will happen? The moment I release this, the stone will go as far as it can according to the elasticity of this material. The same thing is seen in rubber bands, and there are many other things in which we can see the property of elasticity. Is it clear? Now, another topic we are going to discuss is energy due to gravity. Now, again the potential energy will become mgh, where m is mass of the body, g is acceleration due to gravity, and h is height gain. Now, I want to tell you one thing. What is the meaning of potential over here? Potential means the capability or the capacity. Now, potential energy actually depends on height of the substance. Suppose I am standing on this platform and if I get down, I have a very less amount of energy. If I go and stand at the first story building, one story building, then I'll have more potential energy rather than this because the height has increased. And if I move up to the 45-story building, then my potential energy will be of course very high due to the increase in this height. Is it clear? So this is potential energy due to gravity. Now, actually the work done is stored in the in any of the body when it is placed at height with respect to some other point. It is given by mgh. We can derive this formula. Look here. Suppose there is a box M and it has been taken to height h here. Is it clear? Now, in lifting this box, of course some work has been done against gravity. So, we know that the work done is force into displacement. Clear? Here in this case, force is equal to m into a, but here a is equal to g. We know that is acceleration due to gravity. Now, as the displacement is horizontal, that means it is moving upward only. Got it? So what will happen now? This will become h. So by putting these values, I find that the formula becomes mgh, and it is this work done which is stored in this box or this mass m in form of potential energy. Is it clear? Please hold it down till here. Now students, another thing to be explained over here is that the potential energy stored at certain height does not depend on the path through which the object has been taken, or the object where it has been taken, the energy stored in it will not depend on the path up to whatever height it has been taken. I'll prove it right now here. So, what I am going to prove here is that potential energy is independent of path of work done, or I can say that the same amount of work done or energy will be spent whatever path you take to take that thing up to some height. Suppose, I'll give you an example for this. Suppose there is a box here, mass m. So in case 1, what we are doing is we are just taking it up here and the height is h. Is it clear? So in this case, the potential energy becomes mgh. You know why? Because the force has been applied in the direction of motion, or I can say that the displacement has occurred in the direction of force. So when I move this up like this, then the work done is maximum, because in this case the degree of angle between cos theta is 0, and for cos theta when it is 0, that is cos 0 is equal to 1. So the maximum work is done when the force is applied in the same direction with the force. Now, if I take this box via this path, is it clear? Now, this is h1, this is h2, this is h3, and this is total height h. Got it? Now, what happens is, let's see the total work done, W1 is equal to mgh1, W2 is equal to mgh2, and W3 is equal to mgh3. Now what I need to prove is that the total work done is mgh. So here we can see that W is equal to W1 plus W2 plus W3. Is it clear? Now student, I want to say one thing over there. See, when the body is moving here in this way, look here, on the path is straight, so total work done is mgh1, what I have written. But when the body is moving perpendicularly, you can see it here clearly. When the body is moving perpendicular, that is the mass is moving perpendicularly. In this case, the cos 90 becomes 0. Hence the work done in this case when we are taking it horizontally, it is 0. Again same thing happens when the body is moving upwards. This is mgh2, which I have already proven. And another thing is when it is moving again back at this place, it is again 90 degree or perpendicular to the displacement. Now moment it is this, displacement and force are they are perpendicular, then the work done becomes 0. Hence no work is done in moving it horizontally. At these 2 points no work is done. Am I clear? Then again if I take it up here, it is mgh3. Got it? So total work done becomes W is equal to mgh1 plus mgh2 plus mgh3. By taking the common things, it becomes mgh1 plus h2 plus h3. But h1 plus h2 plus h3 is h. So the work done becomes mgh, which is again equal to the potential energy when it was taken in the straight path. Is it clear? So one more time I would like to say that whenever body is moving in this way, that is the perpendicular, or any of the path, whatever path I take, the total energy depends on initial and final destination. It will depend on the height, depend on the height through which it has already been taken. The more example of this I can take is that whenever we try to climb stairs, see, look here, suppose I have to reach at this height h from this ground level g. Got it? Now, if I am moving with this way, then it becomes easier for us because the work done is 0 whenever I am moving perpendicular. But again, if I try to climb directly from here to height h, which is at the same level, then I'll feel more tired. I'll feel off more tired with that. Is it clear? Please hold it down till here. Now I start with the topic power. It is the last topic of this chapter. Given in NCERT. First of all, let's try to understand what this power word means. Generally, it is misinterpreted with the force applied. But students, it's not that it is force applied. Many times we say that he has got more power, the more power he has applied. No, it's not that. Actually, the power is defined as work done per unit time. Now, it is work done per unit time means it is basically a comparative study. It has been used for comparative studies between two objects or two persons doing work or two things doing work. So, it is, the formula becomes power is equal to work upon time. Am I clear? P is equal to W upon T. Now, what is the SI unit of power? SI unit of power is, see, we can find it out. P is equal to W upon T for power. watt is equal to joule per second. I'll write it here. It becomes watt is equal to joules per second. Got it? Now, it is SI unit, and what are the higher units that we can use? No, first of all, let me tell you. Suppose there is a question, it says define 1 watt. So, how will you define it? See, power is equal to work done upon time. Clear? Here I will write watt, which is equal to joules per second, and write 111. Now, how will we define power? When 1 joule of work is done in the time of 1 second, then power is said to be 1 watt. See, when 1 joule of work is done in time 1 second, then power is said to be 1 watt. Is it clear? So, here we can see that for the same amount of work get done, if time is more, then power is less, and if time is less, then power is more. Is it clear? We can just write it here. For same amount of work, if time is more, power is less. If time is less, power is more. This can be easily said here because it is in the denominator, and we know that whenever the value of denominator increases, then the value of answer will decrease. Is it clear? Now, what all are the higher units of power? Let's see that, because the watt is very small unit. So, for that what we use is bigger units. Now, what are the bigger units? 1 kilowatt. Write the symbol separately. 1 kilowatt, and the symbol is 1 kilowatt, and the answer is 1000 watts. Again, 1 megawatt, which is equal to 10 raised to power 6 watts, or I can write 10 raised to power 3 kilowatts. There is one more power which has been used, that is 1 horsepower, which is equal to, one more thing, here we write it with capital M, capital W, and here we write it horsepower like this, and for this it is 746 watts. These are the higher units whatever we use for power, because small units are sometimes very they are not sufficient to explain very large amounts. Got it? Please hold it down till here.